All right. Next up, I'm done with this. So we're gonna bring up the next set of speakers. A couple of my colleagues here, Zeph and Jason, they are senior software engineers, and they are going to talk to us all about what's been going on in PyTeal over the past year. This is the more of a deep dive into how do you use PyTeal, and importantly, what are the improvements specifically for boxes and for the API. Jason and Zeph, welcome to the greenhouse. Welcome to the Developer Tech Talk stage.
All right, Ryan, thank you so much.
You're welcome.
Let's give it up for Ryan one more time. All right, hi everyone. My name is Jason Paulos. I'm a senior software engineer here at Algorand, and I'm joined by Zeph as well.
Yeah, I'm still setting it up.
Just a second. We've got some great stuff to show you today with PyTeal. In the audience today, how many people, by a show of hands, have used PyTeal before? All right, that's a pretty good number. So whether you've used PyTeal or not, I think we're still going to have some interesting content for you.
Oh, there it is.
All right, here we go.
Here we go, yes. So I'm Zeph Grunschlag, and yeah, today we're going to talk about PyTeal. I'll start off by reviewing a little bit about PyTeal, and then we're going to dive into a new capability called application boxes that the most recent version of the AVM is introducing, and how to use boxes in PyTeal. After that, I'll talk about the ABI router, which is how you create the so-called ARC4 compliant smart contract using PyTeal. Then I'll hand it over to Jason, who's going to do a pretty nifty demo. I think you're going to enjoy it. And time allowing, we'll open it up for some questions. So let's talk a little bit about PyTeal. The Algorand virtual machine, that is the AVM, is called every time you make an application call transaction. And it runs by evaluating byte sequences which represent instructions in an assembly-like stack-based language called Teal. Now, many developers prefer to author smart contracts in a higher level language, and so Algorand provides PyTeal, which is based on Python and lets you compose expressions that then get compiled down to sequences of Teal instructions, and then that Teal is run on the blockchain. Now, on the blockchain, this new capability for storage called application boxes is one of the topics we'll talk about, and we'll talk about how you use them in PyTeal. But also, I'll talk about the ARC4, which represents the fourth Algorand request for comment, which describes the ABI, that is the application binary interface, which you can think of as a set of best practices for interacting with Algorand applications. In particular, it describes how to encode rich data types, how to make method calls, and also how to publicize what your contract is doing through a JSON file, which you could think of as like, if you've ever programmed in C++ or C, it's kind of like the .h header files that have the signatures of the actual application. So we are all here in Dubai, and one of the great things about Dubai is the Burj Khalifa, which I can't wait to visit tomorrow. And the Burj Khalifa is the tallest building in the world, and it's my favorite tall building. I'm wondering how many of you agree with me. it'd be awesome to have a poll. Take a poll and see what people's favorite tall building is. Imagining such a poll, I would put the Empire State Building in the poll because I lived in New York for 20 years. Burj Khalifa would be the second choice. And then we have several other choices, 6 buildings altogether. And if you don't necessarily find your favorite building in the first 6, well, go ahead and choose other, the 7th choice. Imagining how this dApp would look like on the blockchain, well, you'd need to have an administrator that could create the app or delete it, and then open it up for voting and close it when the voting is complete. Once the app is open for voting, anyone ought to be able to submit their choice and also query for the status. What does that mean? Well, let's think of an example. I would definitely submit Burj Khalifa as my choice. And if we take a query for the status after 100 such submissions, perhaps we would see that 11 have chosen the Empire State Building in New York, 35 chose the Burj Khalifa, agreeing with me, and so on and so forth. Well, there is one constraint that we want to take care of in such an app. We want it to be a fair poll. That is, we want account 1 to, if they submit choice 2, that's fine, but if they submit an additional choice 4, we don't want both of those votes to get counted. Even worse would be to double count if account 3 could keep on voting for choice 6. That just wouldn't be fair. Well, how are we going to ensure this fairness property? You'll need to somehow keep track of who voted for what. So you actually need to store that information. Applications on Algorand have storage capability already built in. There is global storage. That is, the account that created an application can set aside some storage for the application to use during its operations. The problem is that the maximum amount of storage it can set aside for each application is only 8 kilobytes. And that means that if you're storing each account address of 32 bytes to keep track of whether it voted or not, that's only 256 accounts total. And we want this to be open for more than that limited amount. Another thing you could do, you could perhaps use local storage. Every time an account opts into an app, you can set aside some storage for that account to use in the app. But that's a problem because the account needs to opt in, and we want this to be very lightweight. Opting in costs 1/10 of an algo, and it'll be even a little bit more than that for the storage, and also it creates another transaction, and that's just a little too much friction for what I'm looking for. So come to the rescue, application boxes. Makes it a lot easier to keep track of this information. So what are boxes? It's another key value store. However, this storage, it lives in the account that the application itself has. And it's the term that we use for the keys are names. So every box will have a name and a value. And another convenience is that not only is there an unlimited amount of boxes you could have for this application account, but you can add them as you go along. You don't have to decide at app creation time how many boxes you'll need. And so how are we going to solve this problem in our case? Well, for example, here, account 1 has voted for choice 2. Well, we'll simply save, and then for the name of this box, the address of account 1, and we'll store for its value the byte 2. And if we had 1,000 submissions, that just means we need 1,000 boxes altogether. So how do we actually create and use boxes inside of PyTeal? So PyTeal is making available 7 new methods on the app class. The app class lets you interact with applications and get information about the application, including what is local storage for the application and so on. It also lets you manipulate things about the application. And so there are 7 new methods which are in one-to-one correspondence with the 7 new opcodes which are coming into AVM 8. And so here we see the 7 methods, and I want to start with the bottom 2, which these I would say are like the workhorse methods, box put and box get. So box put is a very handy method. It lets you, for a particular box name, it lets you set the value of the box. If the box didn't already exist, it'll actually create the box in doing so. Box get just gets you the entire value of the box. And if the box didn't exist, it enables you to handle that in a way that we'll see shortly. Now, those are very useful for maybe typical use cases, simple use cases of boxes, but boxes can be very big. Boxes can be up to 32 kilobytes. Their values can be up to 32 kilobytes in length. And the stack of the AVM is limited to only 4 kilobytes. So we can't really create a box with a value of 32 kilobytes at the same time because it just doesn't live on the stack. So when you want to create a bigger box, you'll use box create, but specify the size of the box along with the name, and you'll actually create a box with all zeros for that particular size at that point in time. Box length is another very useful method if you want to know the length of the value being stored in the box. And box delete is a crucial method as well, because one oddity of boxes is that if you delete the application after having created some boxes and didn't delete the boxes beforehand, you will never be able to reclaim the minimum balance requirement you set aside for those boxes. So very important to always delete your boxes before you delete your app. And then there we have 2 last methods, box replace and box extract, which let you manipulate inside a box. You'll definitely need to use them for very large boxes, but sometimes if you have a more complex use case, you might want to use those as well. So let's actually see how we're going to use box get and box put to keep track of voting. So over here, we got a choice. I'm hard coding that choice to be the index, to represent index 1, which was the index of Burj Khalifa. However, in the real application that Jason's going to actually show, it's being received as a parameter, which represents the actual vote that's taking place. Also keep in mind that, yes, we have this key value store, the boxes, which is going to map for any account, the account address, the choice that account has made. We were also going to keep track of a running count. That's going to be kept in our global storage, the older form of storage. So let's actually look at the logic that we're going to be using to store the new vote. So we're going to use our box get method by providing the name being the sender's address. All right? The old choice. An old choice is a PyTeal maybe value. And why is it a maybe value? Because we don't yet know if that box exists. Because the first time the person submitted, the box has not yet existed. The second time, the box exists. And so this maybe value is perfect for encapsulating that determinism. And so what we'll do is we'll call the has value method on that maybe value for the old choice. If it's false, we won't even enter runtime, the rest of the code inside this if block. But if it's true, then we'll enter, the box exists, and now that the box has a value, we can actually query the value. And what we're doing right here in this line is we're decrementing the count for that choice. Regardless of whether this is the first or a later submission, we're always going to want to save the choice for this for the current sender's address or account in its box. And so that's what we're doing right here. Finally, we want to increment the count for that choice, and that's what we're doing in this next part. Okay. So now you kind of see how to use boxes for storing the votes, which is kind of the main core logic of this poll application. How to put the application together. So we have methods that allow us to interact with our app, and remember what those are. Those are create, open, and close that the administrator should be using to manage the app. And we have submit and status open for all the participants in the app. And we have this other operation, delete, which I didn't call a method for a technical reason, which will be apparent in a bit. So as a reminder, every app call transaction has an onComplete action that goes along with it. Typically, the onComplete action is no op. That is, don't do anything apart from running this code. However, sometimes we want to do more things, like we want an account to be able to opt in to an app. I want to let it do the opposite, which is close out, or maybe you want to be able to let it forcibly opt out by calling the clear state. And some of the most of the onComplete actions call the approval program, while the clear state calls the clear program. In our case, the one we're most interested in is the delete application onComplete. That's how you delete an application during an app call transaction. Well, if you think about it, if you want to delete the application, it's just enough to say that's the onComplete. You don't have to provide any extra information. You don't need any arguments. Well, that's why I said that delete was not really a method, because there's a special term for application call transactions that don't have any arguments. Those are called bare app calls, according to the ABI, the ARC4 ABI. So the delete is going to be a bare app call. However, when you do have arguments, those are called methods, and the ABI says that the very first argument is reserved for the selector, and the selector is a 4-byte sequence which will let the PyTeal program figure out which code actually has to be executed. And we'll actually see an example of that. All right, so now I'm going to talk about the router, and every router answers 3 questions, M, O, and E, that is Mo. And for those of you who have no idea who this person is, that's Mo of the Three Stooges. All right. So what are these MOE questions that the router is trying to answer? M is for method. That is, which method is being called? Or if it's not a method, is it a bare app call? The O question is for onComplete. Which onComplete is being requested? E is for existence. Does this app already exist? And if it doesn't exist, well, it means that we're actually creating the app in this very same transaction. So how do you create a router in PyTeal? Well, first you initiate by giving it the contract name and giving it the bare call actions. Now you have a router object. That object has a method property which you then use to decorate Python functions, which are going to become contract methods. Now that's a mouthful, but you'll see this working very soon. Now, once you have the router object and you've attached methods by decorating them, by decorating functions, you call compile program, which creates 3 artifacts: an approval program, a clear program, and a JSON contract. The JSON contract doesn't live on the blockchain. It's kind of like a header file. If you've ever programmed in C or C++, like the .h file, it has the signatures. But the clear and approval program, those will end up on the blockchain. Okay, so let's actually do this. Let's see how this all works. I'm putting a warning sticker here because this delete action is a no-op. I'm not actually giving it any code, which means it'll always say, okay, you can delete that. You don't want that for running application. You want to authorize, make sure that only the correct sender is allowed to delete the application. But again, you'll see the real code when Jason goes through it. So here we are. We're creating the router. We're giving it our name, which is going to be Open Polling App. And we're giving it the bare call actions, including our delete action. We're also giving it this optional parameter for the description. Okay, so we have that router object. The router has a method property. And we can decorate Python functions to create contract methods. So here we are. I'm going to only, for demo purposes, only do one method here that I'm decorating, submit. And again, it's just a shell. There's not real code running here, just to make the slide easier to read. But other things to notice are that there is this docstring that has a special purpose. And notice that choice, the parameter choice, is annotated with this ABI-uint8 type. Okay, what is this uint8 type? Well, the ABI provides a variety of rich types that are encoded in prescribed fashion. So the uint8 is an 8-bit big endian unsigned integer. There are many others. There are uints of other sizes, 16, 32, and 64. You've got booleans and bytes and different kinds of arrays and tuples and strings. The read the doc that Ryan showed before has all that information in there. So let's actually compile the program. So I got the router object. I call its compile program method. I give it a particular version. I'll need 8 because boxes are only available from version 8. And we want to optimize the scratch slots to remove redundant scratch slots. And the first thing we'll have a look at is the JSON contract. So here, remember that the name that I gave the router, it becomes the name of the contract, Open Polling App. The methods, well, I only decorated one Python function, method back, it's submit, and it has some arguments, well, only one argument for choice, and it was a uint8 type. And now docstring ended up becoming the description of this ABI method. What about the approval program? What does it look like? So let's actually look at the code that was generated from this, for this submit method. So this is the teal. And remember, the router is answering 3 questions, M, O, and E. M is for method, which, okay, there we go. Now we're at the top of the code. M is for method. Which method are we in? So it gets the method from, remember the index, the first argument is reserved for the selector, so that's index 0, and it compares it with this, the selector for the submit method, which is generated using this handy pseudo opcode in Teal called method. So it says, oh, is this the submit method? For us, the answer is yes. And then it goes to the branch main L3. Now it's ready for the O question, which on completion, no op. Okay. Now it's ready for the third question. Application already exists. And this is how you ask such a question in Teal. You ask, does this application ID, is it non-zero? When you're creating, so we've asked M-O-N-E, and so now we're delegating to the actual code. And to do that, we need to actually read the application, the method argument. And the first method argument is at index 1. It represents choice, which was a uint 8. So we need to decode that uint 8. How does PyTeal create the teal to do that? Well, we know that uint 8 is just a single byte. So we're going to get that byte at index 0. We put it on the stack, and now we're ready to call the subroutine that implements the code for submit. Now remember that code for submit was a no-op in our case. You'll see the real code. But it's similar to the code that I showed with boxes, but it's going to return right away in this case. And with that, I think I'm going to hand it off to Jason and the demo. Okay.
Thanks, Zeph. All right. All right, so this is the contract that we've written for this demo. I'm not going to go too much into the details here. I just want to give you a very broad overview of the things going on here. First of all, we have a router object right here. This is going to be the central object that our contract uses to actually route between its different methods. We do have one bare app call action, and that is for handling on delete, which is done up here. And then if we go down a little further, we do have here, just keep track of the names of the keys that are going to be used in global state. And we have this variable num options, which lets us control how many options for responses do we want in our poll. In this case, it's 7, but you can change this and recompile if you want to. And then lastly, we have the methods that are going to be defined for our contract. So we have create. This is going to be how you create a new poll with a question and a set of options. We have open poll and closed poll. This is how an administrator can control whether the poll is open for responses or closed. And we have probably the most important method, submit. This is how users will be able to submit a response to that poll, and they'll indicate their choice in the argument up here. Lastly, we have the method status, and this method is responsible for returning information about the current poll. So these are things like whether it's open, what the current count is for each result, how many people have voted for that result, and that's all going to be contained in this poll status object, which is a named tuple, which is kind of an abstraction in PyTeal that lets you create tuples in a more friendly way. And so with that, we just have a statement down here to compile our program from the router. We get our approval program, our clear state program, and our contract object, and we just write those all to files. And so if you want to take a closer look at this code, it is going to be available on a GitHub repo, and we will definitely give you the link to that so you can kind of dive in and see how it works. Next, I just want to briefly show you, this is the approval program that was generated from our contract, and this is the contract JSON that describes our contract according to the ABI, and it has every method that we just defined with all of the details necessary to call them in here. And so that's kind of everything on the quote-unquote back end of this demo here, the smart contract and the information needed to access that smart contract. And I want to show you we have created a front end for this demo. This is a website, and we're using React and our JavaScript SDK to actually interact with the polling app on-chain. And so if we scroll down a little here, we have an option to create a new poll, and I've already populated it with all the information that we want. So we want to ask people what their favorite tall building is, and we have these 7 options to choose from. And I can also control whether this poll allows you to submit another response, to change your response after your first one, and I'm going to leave that as allowed for now. So I'm going to hit create. This is going to send an application create transaction to the blockchain. We're using BetaNet right now because that's where boxes are active at the moment. And all right, so that transaction has succeeded. This is actually our application ID on BetaNet for this polling application. And we have here a few options. This is how you actually submit an answer to the poll. However, if you can see, these options are grayed out. I can't do this yet. And that's because as the poll creator, I actually have access to this admin panel. And this is going to let me open the poll as well as close it to control whether submissions are being taken or not. And I can also see information about the poll. So every application in Algorand has a corresponding account that's used for a few different things. For our purposes, that is where the minimum balance must be stored for the boxes that application creates. So I'm going to fund this account with 32 algos for now, and I'm going to send those. This will be enough for our specific purpose to create over 2,000 boxes of 33 bytes each. And that's going to be, I think, plenty for this demo. So this has gone through. Our balance has increased to 32 algos. And at this point, I'm going to open the poll. And we'll be able to actually send in a vote in a second. OK, so it has submitted. And now says the poll is open. And I am free to choose for an option. So because we are in Dubai, I am going to vote for the Burj Khalifa. And I'm going to submit this option right now. So it is sending a transaction to the chain to actually send that with an application call and create a box that records my vote. And here we go. You've already voted in the poll. I may submit again because I left that option enabled when I created the poll. But what I actually want to show you is I'm heading over to DAppFlow, which is a block explorer. I want to show you some of the transactions that are happening behind the scenes to actually enable this demo to actually work. So this is the account that I'm using currently. I'm just going to refresh this page. And there's a few things that have happened within the past 2 minutes. So this first transaction, why don't we take a look at this? This has actually created our application, our polling application. This app ID is the same one that we just saw on the last screen. And so this is the approval program for the app, our clear state program, and our arguments that were used to create it. You can also see, if you want to inspect the global state, here are all of our options that the poll is going to be using. All right, so I'm just going to click on the application ID so I can get an overview of this. And in DAppFlow, I can actually attach that contract JSON that we generated earlier to this app, and DAppFlow will kind of tell us all of the methods that are associated with that app. So I have a link to our GitHub repo for that contract JSON, and I'm just going to import that right now. And we now have a new piece to the interface, and this is all of the methods that our application supports. So creating, submitting, etc. They're all here. And what I want to do now is I want to go back to my creator account, and I want to look at the most recent transaction, which was me actually submitting a vote into this poll. And we now have this button for the option to view are the transaction arguments decoded according to the ABI. And DAppFlow is able to tell that this was the submit method being called. And our choice argument, we use the value 1. because the index started at 0. Burj Khalifa was our second option. So these are the transactions kind of underpinning the actual operations that our poll is taking. So now I actually want to open this up to everyone here so you can vote as well in this poll, and we'll kind of see which building comes out ahead. Before I do that, I just want to make everyone aware that I'm going to give you a QR code. You're going to see a screen just like this. What's happening is we have randomly generated an account for you that's stored locally in your browser on BetaNet. However, it's not funded yet. You're going to need to use the dispenser right here. Oh, it's going to make me actually do it this time. I hope I get it right. Oh, geez. This was not what I signed up for. Okay, well, you guys can do a better job than me. You hit dispense, you'll be funded, and then you can actually vote in the poll. So let me get that QR code up, and I'd like to invite everyone to scan this and vote in the poll with us. So let's take a few minutes to let you do that. I believe in you guys.
Oh, we're getting some results.
Did it work, Zeph?
Yeah, we got
You
5
voted?
so far.
Great.
10. The tie between Empire State and Burj Khalifa so far.
Yeah, how are we storing the accounts, I think was the question. This is just a demo on BetaNet, so we're not really using what I would call best practices. But what's happening is we generate a new account locally and we store it in your browser local storage just temporarily, just so that this demo kind of has low friction. But in reality, if you were doing this on mainnet or care about security at all, you would use something like Wallet Connect or a similar protocol to let people use their actual wallets to securely kind of work with the application. We have another question up here.
Hope you can hear me.
Yep.
You made a choice to store your options as part of the contract, not inside of a box. Could you comment on that? Why is it not a box?
Sure. Basically, we've talked about the differences between global state and boxes a little bit. But the answer is global state. It's convenient for applications to use because you don't have to specify anything additionally. And we only have 7 options in this case, so global state is, definitely big enough to handle that. But if you wanted, thousands of options, probably a box is going to be a better choice. All right, I think I will refresh the page and we can kind of see how we're doing. 36 submissions. Burj Khalifa is coming out ahead, 36%. Is anyone still struggling to submit? No? All right, well, I'll take that as a success.
I think so, yeah.
Oh, and I do just want to highlight, where is that repo? Here we go. We have a GitHub repo that you can kind of find using this information. And this has both the slides that Zeph has presented as well as the application code that I had briefly walked through. And it's got a link to that polling site as well in case you want to create your own polls and send them to your friends. So there you go, everyone.
Great stuff. Great stuff, Jason and Zeph. Thank you guys so much. That was really cool. Like we had 36 people do it. I mean, like those like most of the people in the room and a bunch online. Awesome. Thanks very much for giving us the intro to PyTeal, teaching us a little bit about how to do that. All right.